Hey everybody, it's good to see you back again. So the try build continues, and this is very much a problem solving episode. We need to put the old thinking cap on, decide how we're going to clear the next hurdle. That being a starting engine block that has a spun and damaged main bearing bore. So about 5 thousandths worth of material has been peeled out of that bore by this old bearing, spinning round and around, and that means a new factory bearing's not going to fit. Well, it'll fit, but it won't be tight enough to stay in place. So we need to, true this out and then turn a custom-sized new aluminum bearing to fit that. That's the easy part, okay? That's not going to be a big deal at all. The big deal is trying to true this back to its original center. So we need to keep the crankshaft on the proper center line to keep it square with everything else, because you have the connecting rods and pistons that are going to be going around and around, and if we let this new bearing bore raise or drop or kick off to the side, you're going to have a crankshaft that's going to be goofy odd angles, and then you're going to have, this is an exaggeration, but you're going to have a rather eccentric motion of the connecting rods, and it's really bad. Plus, you need to think about the gear train. These gears aren't quite so critical because these are the big straight cut clunky gears. They're not like helical cut, but still, if we ended up dropping the crankshaft on its center line out here, we're going to increase the backlash crank gear to cam gear, and we're going to tighten it crank gear to idler gear, vice versa. If we ended up higher than we should be, we're going to increase the backlash to the idler gear, tighten up too much on the cam gear. And also consider, we only have a few thousandths clearance on those main bearings to crankshaft. So if we ended up skewing that thing, a little bit off center, we're going to be binding front main, rear main. Again, not a good situation. And that brings us to this other starting engine block that I've had in my El Cheapo mill/drill here the last couple episodes. I know a few of you in the comment section have pointed that out. So what I wanted to do was mill that bearing bore out with this machine right here, because I have fly cutters I could use. I have these drop down boring bars with drop down bits and everything. I ran into trouble though, because this is not an ideal setup, and to do it, I have to position a block like this because of the stair-step nature of its design, and I have to have it on these other spacers for that idler shaft back there to clear the table. That's all right, not a big deal. So the next step would be to center the spindle up with the large opening for that rear cover. Again, not a big deal. Where I run into trouble though is I have to have the power head raised up in order to center with the spindle, and I don't have a ton of plunge to take advantage of right there. So once I got everything centered up with the head up high, the next thing I would have to do is lower the head down in order to get the spindle and the cutter down to that bore. The way you lower the head is you have to loosen these clamp bolts and then just go ahead and crank the thing down. The problem though, this head is made to swivel on that post. So as soon as you loosen those clamps, you've lost the center. So I finally determined that the mill/drill is not up to the task. So what is our next option? I've still got that boring bar right here. I took that out of storage the other day. It's going to be a good fit in these bearing bars back here. This is the one we used on X231. Poor thing still sitting over here. It's a bookshelf now waiting its turn back in the spotlight. But yeah, we built fixtures and everything to use that boring bar to true up that repaired PTO bearing area in there. So we've already succeeded with it once. Let's try it again. Now, best way to center this in one of those starting engine blocks. I sourced this one. This is a template at this point because it's got all good bores in it and everything. So this is going to be my setup mule. And I also sourced a rear cover and a front cover that I'm not particularly attached to. What I like about the rear cover is it self-centers in that big bore on its own. So that's like 2/3 of my centering bracket right there. So I'm liking that. Then I looked at the front cover, and we locate well with that hole to the shaft for that idler gear like that. We do still pivot a certain amount, so I'd have to find a way to flush out at the top, but then I just don't like that, because if I build a setup for a boring bar, I want it to have convenient repeatability to mount quickly and easily to any other starting engine block that has the same damage, because I've got more here that need this repair. So yeah, at first I was thinking maybe we could bore a hole in here and like mount a bearing, so that's going to support the bar all the way through. Quickly abandoned that idea. That's too much messing around, and I don't think the support's going to be good enough in that anyway. So what we've got done up to this point, and this is also going to kind of show how my kind of odd thought process works, we're just going to conveniently ignore our support problem at the front back here, and we'll just concentrate on the rather workable solution I think we already have in play for the back of the block. And if we can get enough work through here, possibly it'll lead to a solution out there. So we have our boring bar, 1.25 inch diameter. I just happen to have a whole can full of 1.25 inch ID bushings. These were a false start from the Caterpillar 10 track roller repair project. We have some thin wall ones, but we have some thicker wall ones, and I really like these because they're already a close fit to the bar, and I had this old rusty heavy wall steel cylinder that they were just about the right size to fit into the center of already. So I put it in the bandsaw, I lopped off the hammered and beat up end of it, and then put the rest in the lathe. Turned out just the portion that I need. Pressed in 2 of the thicker wall bushings, see on each end, and then precision honed them to be a proper fit on the boring bar. And finally, drilled and tapped 2 threaded holes to retain this sleeve into the rear cover. So we have this rearmost hole that is going to be for positioning the sleeve in the cover, just to mill out those bearing bores. This forward hole is going to locate the sleeve a bit further out of the cover. That's for something else that's coming up on the third of the tri-build blocks. So I'll just show you the fit that we have. I made it to be a perfect slip fit into the cover. Fits tightly, no excessive play. No clearance, no slack at all. And finally, to keep this from spinning or backing out of the cover, that rear threaded hole lines up with that center opening for that bearing retaining dowel. Simply secure it with an Allen head machine screw, and half of our locating system for the boring bar is in place. And sliding the bar in place now, I can decide what I want to do for support out here. Taking a look at it all, it's looking good, and I'm liking this adapter sleeve method, so why not just carry that same idea the rest of the way on out here? We can take into account the fact that this hole for the bearing and this hole for the seal cavity were milled at the same time. So both of these holes share the same center. If we can sleeve into that seal cavity, I think we've got it. After all, I've got a lot of bushings left, and these are the perfect bearing surface, way better than steel on steel. So I'll locate one of these out here, I think probably like an inch away from the block wall, about like this, because we're going to need a little bit of room for some cuttings to fall out. And once the cutter bit gets to the end of the bore here, it might make a couple revolutions before we can stop the feeds. So yeah, we'll locate one of those in that neighborhood. And I didn't have any round stock big enough to turn out for this seal bore. That's 4.003 inches across there, but McMaster Carr had these cutoffs of round stock right here. So this is 4.5 inches across, 3 inches long. That's going to be our working steel to make this second sleeve adapter. So let's get that put into the lathe, and we'll start peeling away excess material that we don't need. Okay, everybody. Believe it or not, it's been 2 days since I last talked to y'all, but yeah, that series of clips you just watched didn't look like a lot, but that was a lot of revolutions of this piece between the two lathes here, and there were a lot of very critical dimensions I had to maintain, so that part of it takes a lot of time. But to break down what you just saw, so we started with the raw blank, and I put it in the South Bend 11-inch lathe out there in the rather unheated portion of the shop. And we just did just the roughing with that, just the quick takedown. We left the outside diameter about 50 thousandths big. I was able to rough in this main pocket in the middle and leave it because that wasn't dimension critical. It just needs to surround this bearing bore bump out and then give us a little extra room for our cutter bit to come through. So pretty much squared off each end, left it again a little bit long. I was able to pop a 1-inch diameter hole in the middle. That's all the bigger I could go with the drill bits and that number 2 Morse taper out there before the taper portion jumped up and I couldn't go any bigger. So we had to leave that at 1 inch for the time being. And then I turned this back part down to about 3.5 because the small 3-jaw chuck on this benchtop lathe back here can't handle that 4+, but it could grab that 3.5 just fine. Then we left that long besides. So once we got it into the benchtop lathe where we could work in comfort in the heat back here, I trued out the outside diameter right here, and this bearing bore is 4.003 inches in diameter. That sounds like an odd size. That's what it is. I measured all 3 blocks. They all 3 spec'd out the same way, and I even verified it with the Master Seal Interchange cross-reference. It also specs that as 4.003, so we just undersized about the first 5/8 of an inch of this, just a little bit below that, so it's just a slip fit. I then took the boring bar on that small lathe back here and I took this out to 1 3/4 to fit the bushing, and then we trimmed down all the excess that was on the back and trued off the front, so everything is nice and square with our finely machined OD. We honed the bushing in the middle and fit it to the boring bar. We'll just do another test fit of that. It's a good fit, no slack, no play, no bind. It slides nice and smooth, so that's exactly what we want for that. Now to show the fit in the block, and this is such a tight slip fit, you have to keep it absolutely square as you guide it in, because if you cock it to the side even a little bit, it'll bind. So it helps to rotate it from time to time to kind of, see, it's tough, kind of keep it square. There we go. It just danced in. So when we're in and square, it rotates freely, but there is no click. There's no play in that. So that's the type of very, very precise fit you need to maintain in order to keep everything on center here. And it's even difficult. You need to dance it out too, because if you get that thing sideways even a little bit, that's all it takes for a bind. So that's exactly the type of fit that I wanted. So our last hurdle now is how do we retain this and keep it from spinning if it should choose to do so. And that's why I left this step on the back, because at first I was thinking maybe putting a plate back here. Wow, I don't know if you guys can hear that wind whipping or not. It's actually beating the door up back here. Man, glad I'm not outside today. Anyhow, I was thinking of putting a plate back here with like a large hole in it that would surround this rear portion, but then come up against that shouldered area right there. And then maybe some standoffs from some of these threaded holes with some bolts to exert pressure. And then it's like, that's still a lot of messing around. So it's easy to overcomplicate things. It's really hard to streamline it and make it effective. So I just stared at it for a while. And then since I've already retained this one with a machine screw and threads, why not do the same to the other? So we have this square opening up here that affords you access to knock that oil seal out from the inside, as well as that round opening right down there at the bottom for the same reason. 1/4 inch by 20 bolts will fit in both of those just fine. So I'm going to mark that out. We're going to drill and tap. We'll bolt it from the inside. That should not only hold it tight, but it should also keep it from spinning. I think we found our setup. This is where you just try really hard not to break the tap off. Just don't break it off. And there's number 2. We didn't break the tap. All right, I've got the block sitting on the adapter on the bench. Let's rotate it around, find the holes. Right there. Line up good. And now to secure it with the bolts, I notched a couple of 1/4 inch pieces of flat steel. They're going to bridge the irregularities in the block wall. Okay, we've got both of the sleeves in place. I got the back one secured, and the rear cover with that adapter is on the block. Boring bar is loaded. Let's just see how we line up. Right through. I am liking that. Good spin. We're not binding. Oh man, this is... I don't know, everybody. I think we're onto something. I can't stop. I can't stop looking at it. It's so cool. And it should be right on center. I mean, you can't look at it and tell that it's crooked or anything, right? So no, it should be right on. It should be a very workable setup, and it's transferable. This piece will fit in any other block. This piece will fit in any rear cover. So you can put this in any setup that you need to repair, and you should have the center line established automatically. So, all right, just to give you all a sense of perspective, this box didn't have any chips in it when we first started. That's from turning out both of those sleeve adapters. That's what we generated right there. A lot of hours standing in front of the lathe. But I think we've nailed the setup. So in my mind, it should work. The next question now is, how do we drive it and how do we feed it? I think I have an idea for that too. You want a hint?